Hello guys, welcome to this tutorial on the integration of trigonometric functions. In this tutorial, we will explore several advanced techniques to tackle these integrals. These include 1. Basic trigonometric integrals. 2. Integration using trigonometric identities. 3. Trigonometric substitution. 4. Integrals involving powers of trigonometric functions. And lastly, reduction formulas. By the end of this tutorial, you will have a solid understanding of how to approach and solve complex trigonometric integrals using these powerful techniques. Let's dive in. The derivative and integrals of basic trigonometric functions are closely related through the fundamental theorem of calculus. So, if we have the derivative and we're going to look at how the derivative of the trig functions are related to its integrals. So firstly, the derivative of sine x dx, we know that is the same as cosine of x. What is the integral of cosine of x? This implies that the integral of cosine of x dx is also the same as sine x plus the constant of integration. Number 2, the derivative of cosine of x with respect to x is negative sine x. So if this is negative sine x, then it implies that the integral of sine x dx is also negative cosine of x plus c. This negative gets itself attached to this. Then number 3, the derivative of tangent of x with respect to x is sec square x, and that implies that if you have the integral of sec squared x dx, you're going to get tangent of x plus the constant. And number 4, the differential of the cotangent of x with respect to x is negative cosec square x, which implies that if we have the integral of cosec x dx, it will produce a negative cotangent x plus c. If we have the derivative of sec x with respect to x, that also produces sec x tan x, and that means if we have the integral of sec x tan x dx, we are going to get sec x plus c. Then the number 6, differential of cosec x dx is negative cosec x cot x. Hence, its integral cosec x cot x dx is negative of cosec x plus c. So with these 6 different integrals, the reverse form of the differentiation is what gives us the integration. But there are others like tangent of x, cotangent of x, secant of x, and cosecant of x. That's when we integrate, it produces a ln of whatever function that we have here. Now let's take a look at them. So number 7, the integral of tan x dx equals ln of sec x plus c, or the inverse of secant is cosine. Hence you will also get negative ln cos x plus c. Then number 8, the integral of cot x dx is what we have here, the ln of cosec x. But here, because you have negative, there will be negative attached to it, or its inverse, which is ln of sine x plus c. Then number 9, if we have the integral of sec x dx, we know that the differential of that is this. So it's the same trig functions, but it will be ln of sec x plus tan x plus c. Then lastly, the integral of cosec x dx gives the differential of cosec x is this. So the same thing, but this negative come in between them, and that will be ln of cosec x minus cot x plus c. With this relationship created, it becomes easier for you to remember the various integrals because you need to know them. Now let's apply this idea in solving some basic integrals. Firstly, let's evaluate integral of sine 4x dx. First, we need to represent the angle by u. So we're going to say let u equals 4x. Then we differentiate the u with respect to x. Making the x a subject, we are going to get the u on 4. Then we place everything here to be in terms of u. Hence, we are going to have sine u the u on 4. We're going to get 1 on 4 integral of sine u du. In so doing, when we integrate sine u, we learned that will give us negative of cosine of u plus c. But u is 4x, and that implies that our answer becomes 1 on 4 cosine of 4x plus c. Note that reciprocal of the differential of the 4x was later multiplied by the integral of the sine 4x, which gave us the negative 1 on 4 cosine of 4x. In so doing, in general, we can say that anytime you have integral of sine ax dx, it gives us the integral of the whole thing, which is negative cosine of ax times the reciprocal of the differential of the angle, which is 1 on a plus c. Also, the integral of cosine of ax dx will give us the integral of cosine of ax, which is sine ax plus c. And we multiply this by the reciprocal of the differential of the ax, which is what? 1 on a. Notwithstanding, also, assuming we have tan ax dx, that will also be 1 on a ln sec x plus c. Sorry, there will be a here. So this simply means that anytime you have a function, say cosine of 4x plus 3 dx, the integral of the whole function, and that is sine of 4x plus 3 times the reciprocal of the differential of the argument 1 on 4 plus c. Let's consider this integral of sec 3x plus 7 dx, and applying the generalization form, it simply means when we integrate sec of a particular function, that gives us ln of sec 3x plus 7 plus tan 3x plus 7, then the differential of this, that is 3, and we try to reciprocate that plus the constant of integration. Also, assuming we have integral of sec square of 3x plus, let's say 8 dx, that also will give us the integral of the whole thing is tan of the function 3x plus 8. Then the differential of this will give us what? 3. So 1 on 3 plus constants. Finally, let's consider this nice problem. Integral of tan ln x on x dx, which is equal to, so over here, when we let this one to be u and we differentiate the u with respect to x, we are going to get 1 on x, which will come and cancel this x for us to integrate. So let's say let u equals ln x, which we know that the u is equal to 1 on x dx, of which when we make the dx a subject, the x becomes x du. So let's substitute everything into this, which becomes integral of tan u on x by, now the x is x du, of which this will cancel that, and that will give us integral of tan u du. When we integrate tan u, that will be ln of sec u plus c. When we substitute the u back, that will be ln of sec ln x plus c, and that will be our answer. Thank you very much for watching. Please subscribe and share this video to your colleagues too. Bye bye.